In this video, our focus is Cartesian and polar coordinates. But you may ask, what are Cartesian coordinates? Cartesian coordinates tells how far from the origin to move along the x or horizontal axis and y or vertical axis to a specific point in two-dimensional space, right? Example, 3, 4 is a movement 3 units in the x direction and 4 units in the y direction. Now I'm going to make a graphical representation of this point here. So now you would have a x and y plane, right? So this would be your y-axis and this would be your x-axis, right? Say that this is 1, this is 2, this is 3, this is about 4, right? And this is about 1 here, this is about 2, this is about 3, and this is about 4. Now if I want to plot this point and this plane, it means that I need to go 3 units on the horizontal. So I'm going to go 1, 2, 3 units on the horizontal. Then I must go 4 units on the vertical or the y-axis. So I'm going to go about 1 here. This is about 2. This is about 3. And this is about 4, right? So this line coordinate would be, let's draw some broken line going across this way, and then 1 from 3 going up. So let's say the point would be about here, and this point would be 3, 4, right? 3 movements on the horizontal, which is the x, and then 4 movements on the y. That would be the coordinate of this point, right? So let's draw a line connecting. Let's draw a line from the origin, which is 0, 0 here, connecting this point, which is 3, 4. So we have a straight line from the origin. Right? Let's call this line here H. So as you can see that this line creates a right angle triangle, right? So it creates a right angle triangle. So what this is saying here, this is saying that the y, the height here is y equal 4. That's what this is saying. And this is saying that x, the horizontal movement, that x is equal to 3. Right? Now, if let's say we want to determine the length of this line, which is h. By Pythagoras' theorem, we could use his theorem to determine what h is, because h here would represent the hypotenuse. So this is just h squared is equal to x squared plus y squared, right? Now h squared would equal to x squared, but what is x? X is just 3 here, so this would be 3 squared plus y squared, which is just 4. So h squared would equal to 3 squared, that is 9, plus 4 squared, that's 16. So h squared is equal to 9 plus 16, that's 25. To find h, you take the square root of both sides, so it would be h squared equal 25. Take the square root of this side, take the square root of that side. The square root cancels out the square sign, so h is equal to the root of 25, which is equal to 5 units. So this length here will equal to 5 units. Right? Now let's say that the angle formed here, we call it theta. And this angle is measured in an anti-clockwise direction from the x-axis. So it is measured in this direction. Right? Do you think that you could use this angle with the length h to determine this point? Yes, you could. And what that is called is polar coordinates. Alright? Another way to express this movement is by way of polar coordinates. Polar coordinates is the angle formed anti-clockwise from the x-axis and the radius of the circle determined by the number of units moved. So here I have an x and y plane, right? And I have a point here. And let's say I want to determine the coordinates of this point in Cartesian coordinates. Then it is the horizontal x movement, the movement along the x, and then the movement along the y. And you get that to be x comma y. But in polar now, it is the angle measured from the x-axis in an anti-clockwise direction to the line that connects the point from the origin. Right? So this angle here, and let's say the distance from this point here is r. So plotting points in polar form would be r comma theta. Right? Now, what relationship can we derive from this diagram here? I'm going to look at all the possible relationships, because remember that our objective is to be able to convert from Cartesian coordinate to polar coordinate, and also from polar coordinate to Cartesian coordinate. So it means that r, theta, x and y must have some form of relationships, right? As you note here, it seems as if r will always be positive, because if I rotate this around the fourth quadrant, I only have one here, r will always be positive. But if I rotate this distance r, this point around, x and y will change based on the quadrant that they are in, because you note that this is the positive x-axis and this is also the positive y-axis. But you also have a negative x-axis and a negative y-axis. So based on where the point is, these x and y values will change. Just a point to note. Now, if we apply Pythagoras' theorem to this right angle triangle, we would have realized that r here is the hypotenuse. So therefore, we could say that one relationship is that r squared is equal to the distance x, which is x squared, plus this distance here, which is y squared. Right? Because that is what the Pythagoras theorem states, that the square of the hypotenuse is equal to the square of the other two sides when you add them, right? So that's one relationship that we could discover. But how could we relate this angle here with these measurements? Let's say we want to take the sine of theta. Here, we could also say sine of theta, which is the angle here, is equal to the opposite length, which is this side here, where y is equal to the opposite length, which is y, over the hypotenuse, which is r, here. Right? So that's another relationship that we could discover. So sine of theta is equal to y over r. But what does this imply? This also implies that if I multiply both sides by r, that y here is equal to r sine of theta, which is the angle. Clear there? What if I take the cos of this angle? We could say that cos theta is equal to the adjacent length, which is x in this case, over the hypotenuse, which is r. So this is just x over r. Right? But what does this imply? This also implies that x is equal to r cos of the angle, which is theta. Because if you multiply both sides by r, then x is equal to r cos theta. Right? So we're getting lots of relationships, right? Now, what else do we know? What if we take the tangent of this angle? We could say that tangent of theta is equal to the opposite length, which is y here, over the adjacent length, which is x. So this is just y over x. Right? But what does this imply? This implies that theta, which is the angle here, is equal to tan inverse of y over x. Clear there? So that's a lot of relationship that we just discovered. So in other words, we could also say that, going back to this formula here, we could also say that this implies that if you want to find what r is, then r is equal to the square root of x squared plus y squared. Make sense there? I hope I'm making sense to you. So if we observe this diagram, where x is basically r cos theta, right? So where x is r cos theta. This distance y is the same thing as saying r sine theta. Because we know that x is equal to r cos theta. And we know that y is equal to r sine theta. We also know that this r here is the same thing as saying r is equal to the square root of x squared plus y squared. These are all the relationships that we can discover from this diagram. Now, with all of these relationships in mind, we can use these relationships to convert from Cartesian coordinates to polar coordinates, and also from polar coordinates to Cartesian coordinates. So what we're going to do is to look at some examples and how we do that.
Thank you for watching. Please remember to like, comment, and subscribe.